All right, and I'll turn the video on just to say hi, tell you that I'm showing you I'm not a recording or whatever. But all right, a few orders of business before we actually start the math. Now today's class, I think, compared to the other topics, I think it's a little, oh thanks, yeah, music. Compared to the other topics, I think it's actually a little easier because most of what we need for what we're doing today, we've already done with polar form. But I'll get into that in a second. I kind of want to do just some housekeeping, which means I just want to cover a few things that are important with the course. So first of all, I want you to complete the practice assignment. So under assessments in Dropbox, the practice assignment is here. I only have one person who's done that so far. It's just a practice assignment in the sense that it's not worth marks, but it's to prepare you to do the assignment 1 on Sunday. You'll see that I've already made a Dropbox for that. The reason I'm giving you the chance to do a practice assignment is to get you used to getting the assignment, finding some way to have it in front of you, and then record your work and send it back to me in a timely fashion, okay? The assignment, hi everybody for coming in. Before I forget, anyone who comes in, just type hi in the chat because I want to make sure I have a record of everyone who is here, okay? So at just some point in the chat today, please, please, please type something so that I can keep a record of it later. All right, so the point of the practice assignment is so that you can practice the actual assignment process. On Sunday, you have 30 minutes to start the assignment, finish the assignment, and give it back to me. Now, technically the assignment's a half-hour long. You can have up to 45 minutes to submit it back to the Dropbox. After 45 minutes, the Dropbox is closed, okay? So from, I think, 10 o'clock to 10:45, that Dropbox is open. If you do not submit it by 10:45, that's it. You just don't get a mark for the assignment. And so any issues like, sir, I couldn't scan it, sir, I couldn't do this, sir, I couldn't find it, sir, I couldn't blah, 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 blah. I won't have any sympathy for that because I'm giving you a chance now to do a practice assignment. So get all of your technical issues out of the way now when it's not worth marks so that on Sunday you're not upset that you didn't get it done, all right? So that's the first order of business. The other point is that, of course, this assignment is on Sunday. Hi, Abdurrahman. The assignment is on Sunday. Make sure you are aware of that and you study accordingly. We are going to finish Unit 1 today. And so the assignment will be 3 questions off any given topic in that unit. Okay, so you need to be comfortable with the whole unit in order to be able to do the assignment because you can get any 3 questions. All right. The next thing would be make sure you keep an eye on the news. I only post one thing, only 3 questions, yeah, 1 page. I'm not making it long. It's half an hour to do 3 questions. It's going to be a page, you know, a regular size page. That's probably not that's regular size. And there's going to be 1, 2, 3 questions. Halas, that's it. Instead of making it 20 questions. So 3 questions that you have time to work on. In the news item, I only post for 1 time every day, but I expect you to read it every day. That's because I do this for you. This is the easiest way to make your way through this course is to make sure you follow what I've asked you to do. So right away, practice assignment. Second, group chat. I think you're all in that now. The YouTube playlists, if you haven't looked at it yet, it's all the lessons. So when I tell you different assignments are all the same, you mean is everyone in the class getting the same assignment? You'll see on Sunday. Lessons 1 to 5, 6, 7, 8, and so on, they're all there. So by the end of today or before today, you should have watched all of these. And I'm assuming that you have because I can't keep assuming that you're not watching it. It's up to you to keep up, okay? The other thing I'll say is I've made a playlist. Let me show you. In content, and again, there's not that much there for a student. Let me show you what it looks like for a student. Under content here, you'll see if you scroll down, I've got YouTube playlists here, lessons and class recordings. So if you open the class recordings, I'm making a separate playlist, which again, you can add to your own YouTube list if you want, of our classes. So we've only had 2 classes so far, so of course there's 2 classes there. You can watch the whole thing. You can jump through it. It's a little easier than what Zoom has made for the video tools. It's better on your phone, for example, things like that. So, you know, bookmark those or find some way to keep track of them. The other thing I'll say is I've posted a bunch of notes. I put the Unit 1 notes and answers. I put all of my handwritten notes there. And I'm also going to post full solutions to everything, every single example and every single practice problem, including any extra practice that I don't get to. Everything will have a solution, okay? Every single thing. Even things that I didn't even talk about will be there. So there's no real excuse in terms of not having enough practice. You should have more than enough practice. And there's enough time in this course to be able to cover all that practice on your own if I don't get to it, okay? We'll cover a lot in the videos and a lot in class. But while you're practicing for your assignments and tests, please, please, please do the practice. That's the only way you can learn this. It's just the way it is. This isn't your first math course. You know that practice makes perfect, right? So that's all I have to say about those notes. And let me make sure I've got everything. Yeah, I think that's everything. The last thing I'll say before we start is make sure you say hello in the chat. I know I said this, but say hello somewhere so that I can make sure that I put you down as present. All right? So before I get back into any of the math stuff, the actual math content, are there any questions about anything I just said or any other thing that came up in your mind since I started talking? Anybody, anybody, anybody? It's okay if you don't have questions, but this is your chance to ask in the beginning.
No.
Right. Well, I know it's Thursday. It's 1:30. I know you probably don't have crazy busy social lives right now. How could you? But I also don't want to waste your time. That's not my intention. I know sometimes I talk a lot, but it's to make sure that I get all the information to you. All right. So hopefully I don't bore you to death. Okay, let's get to it. Just a big picture here as to what we've covered. Up to this point, in the first class, we covered all of these things, everything. We covered basic complex numbers. We covered rectangular form, how to graph rectangular form as a vector. You know, you have your axes and drawing it as a vector. We also did polar form, all of it. That's what we did yesterday, if you were here. And then today, we're going to finish up the unit by doing exponential form, which is basically polar form. I'm just going to be honest with you. It's polar form with one tiny difference. And the only difference is we changed from degrees to radians. There you go. You could probably do exponential form with just that. So exponential form in what's called de Moivre's theorem, which is a way of dealing with exponents. It's very simple. And then we'll work our way down through this list, okay? So today's topic is exponential form and de Moivre's theorem. This should not be news to you because I really am expecting that you've already watched these videos. But if it's news to you, I'll do what I can to get you through, all right? I'm gonna work on the practice problems. So exponential form and de Moivre's theorem. That's a French guy, by the way. He died hundreds of years ago, but we still use this stuff. So it says right here, there's a third form, there's a third form for complex numbers. Remember, we've got two so far, rectangular and polar. The third form is called exponential form, and it looks like this. So it looks very similar, actually, to polar form. Polar form was this. Exponential form takes that angle and just kind of moves it up on top of an exponent. So we still have our r. It is the exact same r. The only difference is now we have our theta on top. So let me separate these. Top one is polar. Second one here is exponential. All right? Small difference. They basically mean the same thing. The main difference, did anyone catch what I said the big difference between them was? The difference is the polar form has everything in degrees and the exponential form has everything in radians. That is the only difference in the way that we solve these problems, okay? So I'll come back to this in a second. Let me just make sure this fits on the page here. There we go. So it says right here, to convert from radians to degrees, we do this. To convert from degrees to radians, we do this. Let me give you a little faster way to write this down. I'll just move over to the side. If you have degrees, so for example, I keep writing that wrong. If you have, for example, you know, I don't know, 50 degrees, and you want to make it into radians, all you need to do is multiply by pi over 180. If you want to come back and go from radians to degrees, you multiply by 180 over pi. Does anyone know how to remember the difference? How to know which one goes on top and which one goes on bottom? I have a feeling I'm going to be talking to a lot of no one today. Okay, so what I mean is, of course, from degrees to radians, we need to do pi over 180. Going backwards, we need to go 180 over pi. There's a lot of students who will mix them up and not be sure which one's which. So I'll show you what I mean, just to be clear. This is just an example on the side of the page, of course. Let's just say you had 70 degrees. And I want to change it into radians. What I need to do is I need to multiply by something over something. The degrees go on bottom because we need them to cancel. All right, that's how you know. Whatever you already have, you got to cancel it on bottom, and then we can transform it into what we need. So you'll notice the radians are on top. It'll become radians. Pi means radians, by the way. And we get our answer. So this is kind of just a basic example. I'll take 70 times pi. You should know where your pi button is on your calculator. It's in the bottom right. Times pi over 180. This gives me 1.22. If you can see that. 1.22, and that's radians now. So I'll just say rad, R-A-D or R-A-D-S. That would be kind of example one. I'll do one more for you, and then it'll be fully prepared to do this. What if you had 3.0 radians? How do I convert that to degrees? Well, you just need to set up the fraction. It's either 180 on top or on bottom. Where's the 180 going to go? Where's the pi going to go? Well, maybe you're thinking about this, maybe you're not. The pi needs to go on bottom, and the 180 goes on top. That's because the radians here cancel with a version of pi on bottom. You know, it's actually pi radians, and they would cancel. So it cancels the radian units and gives you degrees. So at the end of the day here, hopefully you're following along with me. You can't learn this stuff just by listening to me. You should work it out at the same time. This is 3 times 180 over pi, and that's 171.9. Now we have a degree answer. Okay, so that will set us up for the rest of the course in terms of converting angles. Is there anything I can review on that before we actually do the questions? The reason I look over here is this is where my second monitor is, where I check the chat. Abdo says no. Here, I'm assuming you're okay. Ibrahim, Kevin, Mohammed, Zara. I've got 1, 2, 3, 4, 5, 6, 7 students. I'm supposed to have 20 students. I'm supposed to have 20 students in this class. I don't know where everyone is. Lost. Okie doke. Well, let's move on. I just like to check in, okay? Just to make sure you're still alive out there. Let's do it. Convert from exponential form to rectangular and polar forms. Let's make sure I've covered everything I need to know. Of course, this is our exponential form, this is our polar form, and this is also polar form, okay? We just need to change degrees and everything else is cool. So what form, this is practice 11A, what form is this in right now? Is it in rectangular form, polar form, or exponential form?
Exponential form.
Exponential. It's in exponential form as we see it right now. So what we need to do right away, we know R. R is 2.5. All right. The angle, you know, just in case, you know, I think it's pretty obvious, but this is R and this is R. The angle is on top, but remember for exponential form, it's given in radians. So 3.84 is in radians. We need to convert that. So I'll just convert it. It's radians, so the pi goes on bottom. That will cancel. 180 is on top. What does that give us? I'm going to just
120.
120?
220.
220. Okay, that's the same thing I had. Sorry, I'm just using my other notes as a reference. Now it's in degrees, and we just can steal it and put it into polar form. So remember, polar form just looks like this, and we have everything we need. We have our angle now. So it's 2.50 angle 220. I realize now I didn't make it clear why I started with polar form. Notice the question itself, it says we need to convert from exponential form to rectangular and polar. And I chose to do polar first. Maybe if you're thinking about this, you'll know why. It's because exponential form and polar form are like brothers, right? They're kind of like twins. They basically are the same thing. Rectangular form is kind of like the weird neighbor next door that we need to do a few things to change, okay? So we've done polar form. This is polar form. Hopefully that was clear. How do we get from polar form to rectangular form? All right, the HIA says -192 and -161. I absolutely agree with you. And honestly, I'm not even gonna write the workings. Oops. I will just remind you how that works. So let me write out the answer first. That's our rectangular form. If you forget how to do that, it's always, yeah, cosine sine. R cos theta, and notice we have theta, of course, and we have R, and then it's R sine theta. We have R, and we have theta. So that's where those numbers come from. I'm not gonna go through it again. We've done that many times already, okay? This question's done. So as a recap, we got it in exponential form to begin with. We take it, change the angle, now we have polar form, and then we go back and get rectangular form. So kind of 3 big steps, all right? What I'd like you to do now is try B. And I would say these questions should take you maximum 1 minute. But I'll give you 1 minute just to give it a shot, okay? Let me know what your answer is. Okay, I'm back. 140. I just like to break things up. You don't need to stare at me this whole time. And I like to give it time to go in the chat. So Dahia, you did the example, but actually you're right. You were right for the example. Abdo, your answer is not quite right because you have 125 for the decimal. That's not right. You're also missing the J. So let me show you how I would work this out. First of all, I can see R there. You don't need to write R. If you want to write R to the side, you can, but you don't need to. The important thing is the angle. We're given 3.00. It's already in exponential form. So this is radians. We're going to multiply it by pi on bottom to cancel the radians and 180 on top. Okay, that'll cancel the radians with the pi. Now what does this give us? What I got was 172. I'm assuming we're okay with that. Let me just see what you all said. I'm going to get rid of participant list. Again, if you don't say anything in the chat all day, I can't keep track of your attendance anymore. It's just too much work. So I'm going to say 172. That's degrees. We can take polar form directly from that. 0.800, angle 172. Done. That's our polar form. All we need to do now is 0.800 cosine of this, which I got negative 0.792, and I got 0.111 J. So that's not what everyone got. Ibrahim got that. Excellent. Tahia, you got that. Abdo, you had an issue, but did you figure out what your issue was?
Yeah, I got the angle 171. I didn't 172. That's why.
Let me see. So yeah, 171, but it's 0.8 or 0.9, so you should have rounded it up. The angle really was closer. This is kind of the full, a bigger version, so it should at least be 172 if you round it. Or some students would take this. All of it's okay. Honestly, if I saw your workings, I'd probably still give you the mark, okay? Because it is distance, it's a weird time, and so on. Okay, cool. So I'm gonna move on and show you another way we can approach these questions. You'll notice the difference now is we're converting to exponential form. We already had exponential form before, now we're going to it. So these examples are done in the videos. I'm just gonna skip them. That'll be regular practice for me now, is to skip the examples. I'm gonna go straight to the practice. Convert to exponential. So just as a reminder, we want it to be in the form R, E, J, theta. The exponential means the E part, of course. If you have trouble remembering that, the exponential part means E. And of course, there's a power, which is an exponent. So what do we have? We already have R. So we just need to change the, oops. We just need to change the degrees. Put the 180 on bottom, that'll cancel it. Cancel, cancel. And the pi on top. And what I get when I do this is 1.19. It's now in radians. Now that it's in radians, I just write my answer. This is easy because it doesn't ask for two forms, just the one, just as exponential. So 1.186, yeah. So you can keep 3 decimal places if you want. Final answer is e to the 1.19 or 1.186 j. Let me give myself some space here. And this is an exponential form, so halas, I am finished, teacher. Hopefully that makes some sense. I'd like you to take a minute to finish writing that down if you don't have it already, and try B. It's a very similar question, it just looks different. So take until 1:46 to try that. Both of those answers are right. Does anyone else have their answer? See if you can match it. if you find that you're, done and you're just waiting for me, always assume you can go ahead, and you can. There's no problem working ahead. Is that it? Yeah, exactly. I know that's, and it's fine. You can take one decimal place if you want. Okay. I'll delete my weird chicken guy. Let's see. We need to do, it's already in polar form. If you'll remember, this is the other form of polar. All we need to do is change the angle first. 245 degrees multiplied by pi over 180 degrees. That'll cancel the degrees, and we get 4.28 radians, or about pi and a half. So that becomes 15.3 e to the 4.28j. Excellent. So everyone who gave that a shot, thank you. I'll move right on to C. C is similar, and I see that here you've already tried it, and your answer is right. So if you want to try D, you can go ahead. For practice C, it's currently in rectangular. I missed the C there. So if you remember, in rectangular, we have to get two things first in order to get it into polar form. The two things we need are, well, are R and theta. Whenever it's in rectangular form, that's how we get them. Does anyone remember the formula for R? Obviously, Bahia remembers it. You square the A, square the B, add them together. So we have A squared plus B squared. This is your B, and this is your A. When you work that out, what you should get is something close to 7.04. Your theta, which we've done before, in fact, we've done it quite a lot already, comes from tan inverse of the B over A. And we're going to ignore the signs because of the quadrant thing. So first of all, I'll get this reference angle and see what I get. So this is tan inverse, I think just 25.3. All right. 25.3 is not correct. It's too small. And the only way that you can really know that is to at least make a sketch of this. So let me just break these up a bit so that we're clear. I want to make a sketch. Remember the rectangular form. Good, Abda. Your angle is wrong for D, Abda. When you make a sketch, we are going right and down. So if we go right and down, it looks like this. Our angle should be between 270 and 360. As a recap of what I said yesterday, if this is in quadrant 4, you must take, your angle will be, you must have 360 subtract your reference angle, or the angle that your calculator gives you, all right? The angle that your calculator gives you is this angle here. You can call it what you want. You can call it alpha, which is the little fish symbol. You can call it anything. The important thing is that you've got to know the calculator takes the smallest possible angle in that quadrant. Okay, and now we'll have our angle. So 360 minus theta is 360. Let me write it over here. 360 minus 25.3. The angle is actually 334.7 degrees. Hopefully I didn't lose anyone there. We need to go another step because this is a polar form thing in degrees. We need it in exponential form. So this is the last step. What I'll say is step 3. We need to take our degrees, oops, and change it into radians. And that gives us 5.84. Okay, so when we look back on this, I see R and I see theta. So I say 7.04 e to the power of theta j. okay? This question does not take as long as I took to explain it. It's important for me to explain it, of course, so that you get it, but I would say this takes maybe 30 seconds to a minute, maybe 2 minutes maximum. So I've got a couple of questions here. Yeah, your answer for D is correct. Zara, you said, how we know that this angle is in quadrant 4. So let me just write a little side note here. Our question was this. Sorry for anyone who's writing that. I'll come back to it. The original question C was this. And what I should have done really is draw the sketch first. So we see the sketch. Notice this means we go right. It's positive, so we go right. And this part means we go down. Remember, because they sort of work like X values and Y values. We did that a couple days ago, or yesterday as well. So we go right and down. If we go right and down, we're in this quadrant. We're in quadrant 4. Once we know where we live, the quadrant that we live in, we can start using our rules. Is that okay? Excellent. Anytime you have a question like that, it really, you can see it doesn't take me long to re-explain it, okay? All these notes get printed. Yeah, I'm wondering that too. So just because I've lost a little bit of time, I'll work through D. You should also work through this question and we'll check our answers together. So first I'm gonna square A and square B and square root them. That gives 12.2. For the angle, I'm going to do tan of 9 over 8.3. That gives me tan of 9 over 8.3. That gives me 47.3. Okay, Ibrahim, I'll answer that in a second, okay? I'll come back to it. I want to just finish this question. So right now, like I said before, I should have drawn a sketch. This is left and up. So if I'm going left and up, I'm in this quadrant. That means I want this angle. It's always with respect to the positive x-axis. The angle that the calculator is going to give me is this one, okay? So that's what the calculator is actually giving us. It's called the reference angle. We have to now, we want this region. So think of it this way. If you have a 180 turn and we were given a little tiny piece of it, if you subtract that piece from 180, you'll get the rest. In short, what I mean is we have to take 180 now and subtract our 47.3. And that'll give us our angle, which is 132.7. So I just wanted to get that finished. In fact, I'm going to finish the whole question and I'll come back to your question, Ibrahim. We still need to convert it because this is degrees. I'll do it all in one line. Multiply it by 180 and pi. This, if I'm correct, gives 2.32 radians. And finally, because we have a solid answer for r and we have a solid answer in radians for theta, we can write our final answer. And that looks good. Good enough to put in a box. Send it home to your grandmother. All right, so before I explain Ibrahim's question, are there any other issues with what I just did there? Okay, so Ibrahim, your question was, how do we know if the angle is too small and to add 360? Or I guess what you mean is, how do we know when to subtract, when to add 360, 180, and those things? Am I correct? Is that your question before I waste anyone's time? Okay, the first thing you do is you have to know what quadrant you're in. Once you know that, you can use these rules. I summarized them earlier. Let me see if I can find them. I know they're up here somewhere. I know they're up here somewhere. I can find you. Sorry, it was a while ago. Yeah, here we go. Just give me 2 seconds. I'm going to do some computer magic. Oh, what have I done? What have I done? Sorry. I hope you appreciate that it can be a bit of a nightmare sometimes doing this kind of thing online. Okay, so let me go back down. It's going to be worth it, I promise. It's going to be worth it. Okay, so we have these rules, yeah? Basically, like I said, you have to know what quadrant you're in. Once you know what quadrant you're in, the calculator will give you one of 4 possible angles. In the first quadrant, it'll give this angle. In the second quadrant, it'll give this angle. In the third quadrant, this one, and the fourth quadrant, this one. Your rules for each are over here. And the reason is just because of the geometry. The calculator and math gives you those small angles, and these are the 4 rules you use. So for example, I had quadrant 2 in my previous question. That's this rule. So you'll notice that I had 180 minus my angle. I had to use that rule, which is this guy there. Okay, do you see what I'm talking about? Okay. Hopefully that is somewhat clear. If it's not clear, I can explain it again. I'll keep this here so that when you go back and look at it online, you can go back and look at it online. All right, that's actually that whole topic. It's an important topic, but not actually that long. Is there anything I can review on that before I move on? And I know I asked that a lot, but there's no use asking me a question about this in 2 minutes, right? We all feel okay? I should play some gentle serenades when you're all waiting. Oh, this isn't in tune. I'll try it again later. Okay. Multiply and divide complex numbers in exponential form. So we already did this in polar form. If you remember, maybe you don't remember, when you multiply polar form numbers, you multiply the r's and you add the thetas. When you divide polar, you divide it and subtracted the thetas. So it's the same thing for exponential. In fact, the reason it works is because of exponential. Multiplying in exponential form, you multiply the r's and you add the thetas. When you're dividing, you divide the r's and you subtract the thetas. Those are the only things you need to look for. So the way I like to summarize this is that when you multiply, the r's multiply and the thetas add. When you divide, the r's divide as normal and the thetas subtract. So you can think of it like the r's do exactly what you expect them to do. If you're multiplying, they multiply. The thetas do kind of like one simpler operation. So multiply turns into an add, which is kind of like multiplying, but not quite. And a dividing turns into a subtract, which is kind of dividing, but not quite. All right, let's see this in action. These are super fast, so I love this rule. All you need to do is multiply the r's. So we have 0.4 times 1.2. That's 0.48. Done. This is multiply, and so we need to, sorry, this is multiply, so the r's still multiply, the thetas add. So you have 0.66, you have 1.08, you just add them together and keep the form that you had. So this should be our answer. All right, just in case you're any bit not sure about this, these guys together give this. These together give this, and the reason for it is that 0.4 times 1.2 and 0.66 plus 1.08. This is the big idea here. We've already done that in polar form. We saw it again in exponential. It's a nice case where everything kind of connects back to each other. Just one second. So I'd like you to try question B. Sorry, my wife just came in. We had to have a little one-on-one chat with my son. They're just going on a bike ride, nothing serious. So you've got 60 e to the power of 3.09. I'm just going to check I've got some other work I want to check it against because I haven't done these today. Yes, I agree. That's right, Abdo. Can someone else give me the answer? Tahia, I'm assuming you're agreeing with Abdo there. So I'm inclined to agree with you as well. These should take not even 30 seconds. The only thing that should take a while is putting it into your calculator. So this is indeed 60. I should put an equal sign on this actually. 60 e to the power of 3.09j. Alors, ça, Bibi. C'est fini, c'est bon. Est-ce que tu parles français? Est-ce qu'il y a une personne dans cette classe qui peut parler français?
Oui, bien sûr, je parle français.
Ah, je ne sais pas qu'est-ce que c'est, quelle personne talk. I've spoken French for 15 years. Okay. C'est bon, c'est de bon langue. Okay, so we have C. I'll just quickly do it. Again, same idea, but because this is division, the r's divide and the thetas subtract. So just do that, okay? 3.22 divided by 1.56 is 2.06. E to the power of whatever, 3.01 minus 2.37, 0.64j. Okay, 7.4. Did I do it wrong or did you do it wrong? I think you might have typed it in wrong. I probably don't need a box on this. 6. And D, I don't need to give you any extra time for this. When you divide these out, what you're going to get is a fraction, or you're going to get a number smaller than 1. So 0.502 e to the power of 0.65j. That's what I got. Is that what you got? Okay. So that's an easy guy. That's an easy topic. We already did it in polar form. The rules are exactly the same. And hopefully you see now why it's the same. It's because the polar rules, of course, they come back to the exponential rules. If you remember, if you had a case like this, where you have the same base, but a division, the exponents subtract. So this is not new. Just like if you had something like this. When you multiply, the exponents add. Same exact situation as we're dealing with now, except we have a j that gets in the way. But no big deal. The j just kind of hangs out on the outside as a common factor. Alrighty, let's move on and do the last set of topics here. We've got plenty of time left. We might even finish early today. Wouldn't that be nice? Yeah, go and relax on the couch for a little while or something. Okay, last big topic, which is finding powers and roots of complex numbers using de Moivre's theorem. What this means, it's kind of like getting, you know, when in math class before you've been asked to get the roots, like where x equals 0. That's what it's called. It's points where x are equal to something special. That's what we're doing with these complex numbers right now, except we're kind of imagining a circle. We won't have to worry about any of this, by the way. I'm just giving you an idea. We're imagining a circle, and we're going to get a certain number of points along that circle. But all you really need to worry about is that we're going to get, if I ask you for the square root of something, you get 2 roots. If I ask you for the cube root, you're going to get 3 roots, and so on. But I'm already getting ahead of myself. Let me explain what's going to get us through this. That's de Moivre's theorem. So de Moivre's theorem is kind of like our multiply and divide theorem. It's just letting us put a polar form number to the power of an exponent. For example, let's just say you had the number 5 root 30. Okay, that's a polar form number. It's a complex number in polar form. 5 root, sorry, not root 30, angle 30. How would I get this answer to the power of 3? Well, some of you might want to expand that into 3 pieces, which you can. I mean, you can multiply by 5, 5, 5. But yeah, we do sort of a distribution. We'll bring the 5 down here and multiply it. Oh, sorry. We're going to bring the 5 down there and get it as an exponent. We're going to bring the 3 down here and multiply it. Or in a little clearer way, let me show you. It's 5 to the power of that 3. And then inside here, it's not a power. It's one step easier than a power, which is multiply. So it's 3 multiplied by 30. All right? That's a long way of explaining this question, but I wanted to make sure it's clear. So 5 cubed is 125. And then 3 times 30 degrees is 90 degrees. And then we're finished. So that would be the answer to this little example that I just made up. I'm going to put it over here so that it doesn't get in the way. So long story short, we need polar form to do this. And it is a way of getting powers of polar form numbers. Let me show you what it looks like for our examples here, or for our practice. So use de Moivre's theorem. Use our, it's almost like a power theorem for powers of numbers, squares, and so on. What do we have? We have 4 minus 3j to the power of 4. This is rectangular form. I think we give up and go to sleep now. Oh, you're not going to go to sleep? You're going to try and get it? Okay. All right. Okay, cool. All right, no problem. That's fine if that's what you want to do. Let's just keep going. That's no big deal. I mean, no one's going to yell at you for making sure this class goes on. Yeah, we need to make sure we change it to polar form first. So we need polar form. And when you said you need to use Pythagoras, I 100% agree with you. A squared plus b squared. So it's 5. I'm not going to show you why. We've done that so many times now. For theta, it's tan inverse of the other stuff, which is 36.9. That's tan inverse of 3 over 4. We need to change it into, we need to use the reference angle idea again. Because we can't trust that number until we know if it's a reference angle or not. So it goes right and down. So it's in quadrant 4. If it's in quadrant 4, what do we do? 360 equals 360 minus. 360 minus 36.9 is, let me see, 360 minus this guy, 323.1 is what I got. Plus, yeah, you're working through it, it's okay. And that's 323.1, that's our angle. I'll make it and put it back in black. Back in black, hit the sack. It's so long, glad to be back. Do you know that song? AC/DC? Sorry, I'm so tired. Okay, we're in polar form now. 5 angle 323.1. Why do we have this polar form number? What were we even trying to do? Well, we were trying to get a power of 4. So this is the number we care about in polar form, but we still need to get the 4th power. The reason for that is, of course, we have this power 4 there. We need to get the power 4 of the number. That, thankfully, is the easy part. we just take 5 to the power of that 4. And then we're going to go 4 times the angle that we have. You can also write it as this. I mean, some students prefer to put the 4 at the end. It's up to you. I don't care. That answer is, yeah, 625. Sounds peachy keen to me. And then we have, whoa. I don't know about that number. Sorry, 92.4. Let me rearrange this for a second because I have one thing left to do. I know you can't do this, but I can. All right, that number is not okay. 1200, yeah, you got it, Ibrahim. 1200 is, if I just draw a sketch, I'll delete it. This is 360, and this is 720, and this is 1080, and then 1292 is something like that, okay? Around and around and around. That's useless. Why would you do that? So what we should do is subtract 360. We subtract 360 and it deletes that much. We subtract another 360. Subtract another 360. And now we have our angle that we're looking for. We just keep subtracting until we get what we want. So subtract 360. What does that give us? 1292.4 minus 360. That gives us 932.4. That is too big. Subtract 360 again. 572.4. That's too big. Subtract 360 again. 212.4. Okay, that's the one. That's between 0 and 360. So I'm going to write out my final answer. Okay. Now we're done. Now you don't need to write those little pencil markings. That's me trying to help you think about this in the way that I think about this. You just write as much or as little as you need to get you through the question. One thing I will mention to try and help you do this stuff as fast as you possibly can. If you're using the Casio, now this might be old news to you, but I'm going to put in my angle, 1292. I got to get a mouse for this. 1292 minus 360. I'm just trying to save you some time, okay? So the answer that you get is 932.4, which I already said. Of course, we're going to subtract 360. Don't type the number in again. You know, just press the subtract button. It'll keep the previous answer. Press equals. We get 592.4. Once again, you should pretty much never clear the calculator unless you're starting again, because we obviously need to subtract 360 again. So just press minus and subtract 360 again. All right. Some of you might be rolling your eyes at me and being like, are you serious? Are you actually telling me this right now? But there are some students who don't know that. And you were that student once upon a time. There's always a time where you don't understand this stuff. So I'm just trying to help, just trying to help. That goes for any case where you need the answer, okay? So A is done. What do you think I'm gonna ask you to do now? Is anyone still awake? B and C, B and C. Now, I'll do C, but if you want, I'd like you to try B and D. And if we have issues with D, I'll go back and do C, okay? So take 3 minutes, 4 minutes, and try those questions, B and D. They look different, but they're not. And let me know how you do, okay? Type your answer in the chat so I can see it. If you feel comfortable, I'm not gonna make you do anything you don't wanna do. Although I'm not going to answer that exactly, but I will draw you a sketch, which hopefully tells you what to do. 7.3 is fine, Zara. Okay, so I think I said 3 or 4 minutes, and I think that was 3 or 4 minutes. I don't know, I forgot to look at the clock. But that's probably long enough. Zara, is that okay? You gave me a scrunch face. It's all right? 7.28, 7.3? Exact. Well, it's not exact, actually. Root 53 is exact. It's an irrational number, which means it doesn't have an exact answer besides the root. Okie doke. So we have everything we need. What were we trying to do? Oh yeah, we're trying to write out the roots. So I'm just going to take root 53, angle 105.9 degrees, and I'm going to go ahead and put that to the power of 3. Because remember that's the actual question. We just couldn't do the actual question until we had it in polar form. What we end up with is, just the first time I'll write out the full work, okay? I won't always write out the full work because I want to save you some time. 3 multiplied by our existing angle. And drum roll, please. What is it? 385.8, I think, is what I got. Now I'm seeing different answers here. 317.7. This is what I got. How are we getting 389? How are we getting 315? Did I do something wrong? Uh, 380, I should get about 386. If you use 7.3, you should get 389. If you use 7.28, you should get 386. Okay, all good. As long as you've kept some workings and you haven't broken the method, again, I'm not going to take the marks off. I don't think that's fair. As long as you know what you're doing, I'm going to give you the marks for that. Okay, so that's that whole question. Nose is itchy. Yeah, no problem. So hopefully that's clear. I will do one more of these because really they're all the same. They're very similar. Let me know if you need me to scroll back up. I'll scroll back up. So in this case, I don't know, let's take a vote. Do you want me to do C or do you want me to do D? First person gets a free answer to the question. All right, Kevin beat you to it, Zara. So they're both basically the same. So I'm going to do D. The answer to C, by the way, I'll just do it really quickly, is 81 cos 40 plus J sine 40. You can check that yourself, see if you can figure it out. For D, what we'll notice here is that it is in polar form, just in the expanded polar form. So we need to do 8 to the power of 5, which is 327.68. That's a huge number, but no big deal. And then the angle is 80, but it's 5 times that. So 5 times 80, 400. Let me keep the form that it was in, because sometimes that's useful. I'm just matching the original form so that you see that it does work the same way. It's the same idea. Is that okay? Are you sure? Are you sure? Are you still sure? We don't want any angles above 360 because we want to rewind it so that it's between 0 and 360, all right? So make sure you take away 360 for these. Once you do that, we can describe it, or that's the angle, okay? And I'll show you one more time why it works the way that it does, okay? So So this is our answer. This is our final answer. So I'll show you very quickly why we don't want 400. The angle 400 is around 360 and then around again. So we would go one full turn, 360, and then we'd have to go an extra 40 degrees in order to give us, in order to give that polar form. Well, why bother going a full turn first? Why not just give us this angle? That's 40. The blue angle here is 400. There's no real need to go around the circle that many times. Okay, that's what's happening here. They are technically the same thing, but we want simplified form. Okay, so hopefully that makes a bit of sense. I'll keep that here just so you can look at my pretty pictures later if you feel like it. All right, E and F, I'm not going to do. Those are just easy homework questions. They're the easiest ones. Is there anything else I can go through before we do the last topic in the unit? Do the last topic, get it out. Try to finish early so you can have your 5 minutes break. The weather today is crazy. It's not too bad over here. What do you see on that side? Oh, it didn't rain here yet. Maybe I have something to look forward to. Right now it just looks boring outside here. It's kind of cloudy, depressing. We'll see. We'll see. Okay, I think I've delayed enough. let's finish. Once again, and I've said this before, but I want to be really clear about it. If there are any questions that I skip, it doesn't mean that they're not important. It just usually means I've done questions similar to them. But you shouldn't be skipping any of the questions on your own. You know, when it comes time to do the assignments or practice for the assignments, please do the questions that we didn't cover. That's the only way you're going to know if you can do this stuff. It's great to do the questions we already did, but the assignment questions are going to be new questions as well. So you might as well try the questions that we didn't do in class to make sure that you know that you're prepared. That would be my piece of advice for the day. Okay, so last topic here. It says de Moivre's theorem is true for all real numbers. We can use it to find fractional values of complex numbers. That might not make sense to you, and that's okay. We don't really need to worry about what that means. It is important that we talk about fractional values for complex numbers, and any fractional values of complex numbers are known as roots. What this means is that you can have a number, for example, well, it's down here, 2j. We want, if we have the number 2j, we want the square root of 2j, and we're going to call that x. Sometimes we'll call it x, sometimes we won't call it anything. But we want to get the square root of a complex number. That's the whole point. And it's a 4-step process. It's a little bit confusing the first time around, so I'll try to make it as clear as I can. But just stick with me. It should make sense once you look back on this, okay? Sorry, I'm just getting my, my reference notes here, just because I don't want to waste anyone's time. So it's a 4-step process. The first thing that you need is you need it to be in polar form. Then you need to express the root in fractional form. What that means is if you have a square root of 5, for example, we want to call that 5 to the power of 1 over 2. All right? That's the same thing as square root of 2, remember, means power 1 over 2. You've definitely done this before in math. What this means is there will be 2 roots. That's because whatever type of root it is how many roots we're going to get out of this. That'll be clear soon. Now, we want to use de Moivre's theorem to find a root, and then we're going to add 360 a certain number of times. This probably doesn't make any sense to you yet, so let me do an example so that you can see how it all comes together, okay? So find all square roots of 2j. First things first, we need polar form. what is 2j in polar form? Well, think about the sketch. What does 2j look like if you were to graph it?
90 degrees.
What did you say?
It is going to be like a 90 degrees because it's J, so.
Exactly, yeah. It's straight up. So what that means is the number 2j is actually 2 angle 90. So our polar form is 2 angle 90. That's the first thing. Now, it doesn't need to be difficult to find. In this question, it was actually very simple to find. Once we have the polar form, you'll see that that's actually the first step up top. Now we have to express the root in fractional form. So what we do is we'll say 2, we want the square root of this. So we need to get the square root. It looks like this. 1 over 2. That is the square root of that number. You'll notice it's the same thing as saying this. 2j power 1 over 2 is the same thing as 2, 90 degrees, 1/2. Okay? That's why these things are connected. So, are you with me so far? How can I possibly solve this? Well, we use De Moivre's theorem. We know how to solve this. We bring the 2 down. So this is 2 to the power of 1 over 2. The angle, what do we do with the power? We always bring it down next to the degrees, or next to the angle. And the 90 is there. All right? So all we really did so far is change it to polar form, and we added the root to the top. But it's not really new. It's kind of half new. What is this going to give us? What's 2 to the power of 1/2? Well, it's the same as root 2, isn't it? So this is root 2, and this is 45 degrees. So I'm hearing some dinging. I don't know if there's new students coming in or not. It's a bit late if anyone's coming in new. But are you with me so far? What I've done, does it make some sort of sense? Here, I can see that you got it done. Is that a yes or a no or a, oh God, help me? You don't know. Okay, let me finish the question and we'll do another question like it, and then you can start to see how these things are piecing together. First time through, maybe I should just not stop. Okay, so we did it in polar form, we got the root. We need to change this into rectangular form. Do you know how to do that? Of course you do. R cos theta, R sine theta. What you'll get if you do this is 1 plus j. That is our first root. That's the first root that pops out of this answer, okay? Let me shift this over because I need a little bit of space. I'm sorry if it's a little distracting when I do this. I don't mean to be distracting. Okay, so we've managed to get our first root. It needs to be in rectangular form. It's just the way it is. We need it in both forms. And oftentimes roots are better expressed as rectangular form, okay? So something to keep in mind. We need to get a second root. And let me show you how this works. I'm just going to tell you what you do. Everything is the same. We only have one root right now. We need 2 roots. This is a square root. We need 2 roots. You know, square roots means we need 2 roots. So what we do is we add 360 to our 90 here. I'll make it in blue so you don't miss it. We add 360, it just is one way that it'll allow us to go around this circle again and search for roots. So what's 90 plus 360? It's 450. Just trust me for now, this is just the method that we use, okay? It's still 1/2 of this. And we go through the same process again. It's still going to be 2 power of 1/2. The difference is the angle. It's half of 450 this time. And that's root 2 Angle, what's half of 450? 225, thank you, Abdul. 225. And then, if someone can give me the answer for this, just so I can see you're awake. Maybe Ibrahim or Kevin, you guys are pretty quiet. What about Muhammad? What about Zara? You know, give me an answer here. This is the last, the last thing to write for this whole question. Remember, we just want r cos theta, r sine theta. I'll give you a hint. -1 minus j, okay. You got it. That's our second root. Oops. So when you finish these questions, you need to make sure that you've added 360 enough times so that we now have 2 roots. We get 2 roots when we square the numbers, okay? Sorry, there's a lot of red on this page. I hope that's all right. Let me just shrink this down a tiny little bit so that it fits on the page, because you never know, maybe you want to have better notes later. This is done. So let me recap. Let me finish, let me go back over what we did, and we'll do it again fresh with a new question. I needed to get the square roots. So I needed to get it in polar form, then put the root there, and then all I do is go through de Moivre's theorem. We do de Moivre's theorem once. We add 360 to the angle, and we do de Moivre's theorem again. We do it until we get as many roots as we have been asked for. Okay, so let's go ahead and try another question, assuming that I can move on, like move up the page. If you need me to move back, I will. So we need to find all complex roots of this equation. Before I start, how many roots are going to come out of this question? Four. That's exactly right. There's going to be 4 roots. The reason we know this is called n. N is 4. Our power of, which relates to the roots is n. We've got 4. So we should have 4 roots, which means we need to do this plus 360 3 times. That'll be the original de Moivre's and then 3 extra de Moivre's theorem. Let's see what it looks like. First of all, this is not in the form that we need it to be. We need to solve for x. 16. This step kind of freaks some students out. Do not solve fully for x. You need to keep the exponent. You know, you need to keep this root here because that's what's going to let us solve for the complex numbers, or for the roots of the complex number. So we're going to get it in polar form. I can make a little sketch here. What is 16? You know, I'm just looking at the 16 here. Oops. What is this 16 in polar form? Angle 0? Absolutely. It looks like this. That's our 16, angle 0. So it's just 16, angle 0 degrees. I'm going to include the 0 angle because I need to add 360 to it. So I want to keep it there as a kind of like something we can work with later, okay? So we have our polar form. Now we'll start getting our 4 roots. We give space for 1 root, space for 2 roots, space for 3 roots, space for 4 roots. All right? First things first. Put your number down with your degrees, and we need to get root 1/4 of this. We'll do the same thing we did before. We'll do 16 to the power of 1/4 is 2. The angle is still 0 exactly, because 1/4 of 0 is still 0. Now, I'm thinking, because this is probably the only time I'm going to show this, I'm going to show more work. You can skip this work if you want, but I think it's important for those of you that are still trying to figure it out. Okay, now that we've got that step done, we have 2, and then our angle is, of course, 0. We change that into rectangular form and we have our first root. That should be 2. That's our first root. How did I get the angle? Is your question, Zara. I know what the angle is because, let me try to make this clear. This number here, 16, is the number we care about, all right? That is our real number. We need to sketch that. I sketched it over here, and we can see that it's right along the x-axis. It only has a real part, which is right on the x-axis at 0 degrees. There's no j, so it's 0. Yeah. So the number is, just to be clear, this is 16 plus 0j is really the number that I'm working with here. So if you graph that, you get 16. There's no angle. Okay, I'm going to finish the question. I don't want to. Okay, good. I don't want to waste anyone's time. This is 16 angle. What do? We add 360. You don't need to add this in here, but I'm going to write it in pencil, just so that you remember. Add 360. That will allow us to collect the next root. 16 to the power of 4. You could just write 2 there if you want. I'm just going to have full workings so you can look back on it. This is a quarter of 360. So we end up with 2 angle. What's a quarter of 360? What's 360 divided by 4? 90 degrees. And I remember seeing this in the chat. Exactly. So 2 cosine 90 is 0. 2 sine 90 is 2. So we end up getting 2j. All right, remember, if you're trying to remember how to do these, you got to do r cos theta plus r sine theta, and you stick a j on the second one. I'll keep it there. All right, so we've got a little ways to go. We got 2 more roots to get. Why do we need 2 more roots? Because we are supposed to have 4 roots when we finish this process. I'm going to write it out. You can do the same thing with me. I'm just going to turn off the video for a second, but you can try these and see what you get. You've got 2 and 180. That's exactly right, Dahia. Okay. Okay. Now my back hurts. I had to buy a standing desk when we left the college, and it doesn't seem to matter. Oh, it's like there's only so long you can deal with a computer before you start crouching over like an old man. I mean, I'm only 33. I'm not that old, but yeah, I feel like my spine is a curve now. So anyway, that's life. Anyone who had me last semester knows that I don't have the best back anyways. So no, I'm not sitting down. I mean, I can jump. I can jump. Yeah. Anyway, no, I'm standing up on purpose because sitting down is actually worse. if you sit down for too long, your spine tends to be even more curved. And if you do that for 8 hours a day, you start getting back problems, right? So anyway, let's finish up. The reason it has 4 roots is because of the 4, and hopefully the rest is clear. There was something I wanted to say, and I'm just trying to reach back in my memory bank to figure it out. It's lost. It's lost. So the questions I want you to try here, and we'll finish up in a minute, is well, I want you to try all of them, honestly, but I want you right now to do E. I've got other ones labeled that I was thinking of doing today, but I'd like you to try to do E. That'll be the last thing we do today. There is a question on the assignment on de Moivre's theorem. That's why I'm trying to get this out of the way now, so you can study it over the weekend. This is x power 5 equals negative 32. That means that x equals negative 32 to the power of 1 over 5. As a polar form number, that is, I'm going to make this smaller because I'm going to run out of space really quick. As a polar form number, we have, let's see, negative 32, 180. So really we have negative 32, oops, 32, angle 180, power 1 over 5. That's what we need to deal with, okay? So we finish class, what, in 5 minutes? Yeah. I'll give you the final answer for this so that you have a reference. And then if we run out of time today, you'll at least have the final answers. So just give me a second to write those out. What? What a useless tool. Sorry. Okay. All right. Feel free to work on this now so that you know if you're doing this right. If you can do this question, this is actually a harder question than the one I'm going to give on the assignment. So if you can do this one, you can do the one on the assignment. The last thing I'll say before anyone who wants to leave, you can leave, and it looks like a few people have already left. Please do the practice assignment. That's the first thing I'll say, and just study well over the weekend. We have that assignment on Sunday. We're going to start the next unit on Sunday. It is not a review class. We start functions on Sunday. So make sure that you review well over the weekend. If you have questions, just let me know, okay? I'll be available over the weekend at certain times. I'll get back to you whenever I can, definitely before Sunday. All right? So feel free to stick around and try these questions or this last question. Otherwise, feel free to go. It's up to you. I'll stick around until 2:50, all right? Have a great weekend. Thanks for coming.